Students, now we are supposed to plot output curve for common emitter configuration. Output characteristics of common emitter amplifier is defined as graph of output voltage VC versus output current IC, keeping input current IB constant. So it is graph of output voltage VC versus output current IC, keeping input current IB constant. If we plot characteristics in output side of transistor, then it will be something like this. For different values of base current IB, we can plot different values of IC as shown in the curve, where for this IB is equal to 0 microamperes. For this, IB is equal to 1 microamperes. For this, IB is equal to 5 microamperes. And for this, IB is equal to 10 microamperes. Now, what we have done is, we have plotted characteristics of IC and VCE keeping IB constant. Characteristics of IC and VCE keeping IB constant. Now let's find out different regions of operations. First region is cutoff region. In cutoff region, input and output both are reverse bias. Input is reverse bias as well as output is reverse bias. As input and output both are reverse bias, current due to majority carriers is 0. But from characteristics, we will get that there is small amount of current is flowing when IB is equal to 0, and that current is due to minority carriers. Hence, in common emitter amplifier or configuration, when input and output both are reverse bias, still we will get small amount of current due to minority carriers. And this region below IB is equal to 0 microamperes is called as cutoff. In second region called as active region, in this input is forward bias and output is reverse bias. Now, as output is reverse bias, there will be base width modulation inside the base. And if we change base current from 0 microamperes to 1 microamperes or from 1 microamperes to the 5 microamperes, output current IC is changing or it is increasing. So, output current IC is increasing with respect to input current IB, and hence in common emitter configuration there is current amplification. So it can be used as current amplifier. Similarly, we can find out resistance in output region, which is given as R0 is equal to change in output voltage VC to the change in output current IC, keeping input current constant. For common emitter amplifier, value of R0 will be in kilo ohms, but it is less than common base. Hence, R0 is considered as low impedance value in common emitter amplifier. Now, the third region is saturation region. So, when VCE becomes equal to 0 and IC becomes equal to 0, we can see that the region available is called as saturation region. So, below IB is equal to 0 microamperes, the region is called as cutoff. When VCE and IC both are 0, the region is called as saturation. Region between saturation and cutoff is called as active region, where we are supposed to bias our BJT. Thank you.